Imagine that right now, at this very second while you're watching this video. Trillions of particles are passing through your body. They don't interact with you. They leave no trace. To them, you are merely a ghost. Scientists from University College London claim they found breaches in the fabric of reality points where our universe touches another. Russian experts from the Space Research Institute of the Russian Academy of Sciences simply scoffed at the time, calling it just PR. But the question remained open. Where are they? If parallel worlds exist, why don't we see them? And most importantly, is there another you out there? There are two ways to lose your mind. The first is trying to comprehend infinity. The second is asking a physicist, but where exactly is this parallel universe? And you know what they'll answer? That it's right here, literally a millimeter away from you, just in a different dimension. But today, we're going further. I'm going to tell you about a theory that will make the hair on the back of your neck stand up, just as much as any Christopher Nolan film. We'll figure out where these worlds are hidden, why Hawking looked for their traces in the cosmic microwave background radiation, and what your last big life decision has to do with it all. To understand where to look for parallel worlds, we need to do a little violence to common sense. Imagine you're looking at an electron. It's not just a tiny little ball. It's a ghost. As long as you're not watching it, it exists in all possible states simultaneously. Physicists call this superposition. This isn't a joke. Schrödinger's equation, the main tool of quantum mechanics, tells us the world works this way. The particle is here and there, flying right and left. But the moment you turn on a measuring device, a miracle happens. The ghost becomes matter. The electron chooses one state. Now, the scariest part for a scientist is that Schrödinger's equation stops working at the moment of measurement. It describes evolution, but it doesn't describe why we see just one thing. How does the electron know it's being observed? It doesn't have eyes. Quantum mechanics doesn't answer this question. It only gives probabilities. 50% for up, 50% for down. And this is where an idea emerges that split the scientific world into two camps. What if Schrödinger's equation is never violated? What if the instrument actually shows both results? It's just that our brains are wired in such a way that we can only perceive one branch of reality. When you measured the electron's spin, the universe split in two. In one, you see a red signal. In the other, you see a green one. And both universes are equally real. Now let's recall Schrödinger's cat. It's not just a cruel joke about an animal in a box. It's an illustration of scale. If an electron can be in superposition, then the cat, whose life depends on that electron, can also be in superposition. It is both alive and dead at the same time. Most people laugh. Nonsense. Open the box, the cat is either alive or dead. But proponents of the many worlds interpretation, which, by the way, Stephen Hawking seriously considered in his later work, argue, opening the box doesn't kill the cat. It multiplies universes. Look at how the mechanism works. There's a cat in the box. There's a Geiger counter that detects radioactive decay. If decay happens, the poison is released, the cat is dead. If not, the cat is alive. According to quantum mechanics, before the box is opened, both possibilities are realized. But then you approach the table. The moment you touch the lid, something monumental happens. Your brain, your eyes, the air around you. Cosmic rays flying through the room, the entire environment begins to interact with this event. The environment transmits information. Cat dead, cat alive. And these two streams of information cease to contact each other. They diverge, like ships in the ocean, creating two gigantic branches of reality. In one, you're mourning your pet. In the other, you're happy it's alive and you go make some tea. And here is the answer to the where question. These universes are right here. They are simply different versions of the same room, existing in the same physical space, but they can no longer interact. It's like two waves on water that rush towards each other but pass through, never noticing the interference. But there's another theory, a more global one. Hugh Everett, who came up with the many worlds interpretation, suggested looking inside quantum processes. But string theory and inflation theory talk about cosmic scales. Imagine a boiling kettle. Bubbles of steam appear here and there. Well, our Big Bang is not a unique event. It's one bubble in an infinitely boiling cosmic cauldron. Space-time around us is frothing. Somewhere nearby, in an unreachable distance beyond our cosmic horizon, other bubbles might be inflating other universes. Physicists from Switzerland and this recently recorded anomalous quantum fluctuations at a particle accelerator. These fluctuations cannot be explained by standard physics. One hypothesis is interaction with a shadow universe at the subatomic level. This means parallel worlds might not only be global bubble universes, but also microscopic layers separated from us by just one dimension. Remember string theory. For the math to work out, the world needs 10 or 11 dimensions. We live in 3-dimensional space plus time. Where are the other 6 curled up? They are compactified, twisted into such tiny structures that we don't notice them. These curled up dimensions are the shelf where the parallel books of realities lie. They are so small and fundamental that they exist literally inside every atom. In 2004, a NASA satellite discovered a cold spot in space, a giant region where the temperature of the cosmic microwave background radiation is anomalously low. For a long time, attempts were made to explain this by voids, in absence of galaxies. But Professor Tom Shanks from Durham University put forward a theory. It's not a void. It's a bruise from an impact. Our universe once collided with another. Like two soap bubbles, they touched, leaving a bruise on the fabric of space. If this is confirmed, it would be the first direct proof that the multiverse is not just a mathematical abstraction, but a physical reality. So where are they? Let's piece the puzzle together. First, the quantum level. Parallel worlds are branches of reality that split off every millisecond. Where are they? Everywhere, but in different phases. It's like radio stations. They're all in the airwaves, but your receiver can only pick up one at a time. Your consciousness is that receiver. Second, branes. According to M-theory, a development of string theory, our 3-dimensional world is a membrane brain floating in a higher dimensional space, called the bulk. Right next to us, parallel, at a distance of a fraction of a millimeter in the 4th dimension, there could be another brain, another world. Gravity, by the way, is so weak precisely because it leaks into this gap between the worlds. Third, the cosmos. Right now, billions of light years away from us, other bubbles are expanding. We will never see them because light from there simply cannot overcome the speed of spatial expansion. They are beyond our horizon. And fourth, the most interesting, black holes. Doctor of Physical and Mathematical Sciences Stanislav Alexiev suggests that black holes could be tunnels. The collapse of matter into a black hole in one universe could be the Big Bang in another universe. White holes would be the exits from such tunnels. Perhaps the ultra-high-energy cosmic rays we detect are coming to us precisely from parallel realities through such necks. Just before his death, Stephen Hawking submitted a paper for publication that revolutionized the concept of the multiverse. Along with Thomas Hertog, he tried to solve a paradox. If there are infinitely many universes and they are all different, then our theory predicts nothing. This is called the landscape problem. Hawking proposed a new mathematical approach. He used the holographic principle to reduce infinite diversity to a finite set. And the conclusion was staggering. Parallel universes exist, but they aren't all that different. They are similar to ours. The laws of physics are roughly the same everywhere. This means that over there, in that universe where your cat is alive, you have the same face, the same planet, the same sun. The outcome of events is just slightly different. This isn't science fiction. Hawking asserted that we could detect traces of these universes by studying gravitational waves, or that same cosmic microwave background radiation. He gave us a map. We just need to learn how to follow it. You know what the greatest horror and the greatest comfort of this theory is? The comfort is that death doesn't exist. In one of the branches of reality, you will always be alive. You've read this text to the end and in an infinite number of worlds. You'll close this video right now. The horror is that our decisions have weight. With every choice, we create universes. And somewhere out there, there's a version of you that took the step you didn't dare to. That one conversation, that one letter, that one leap. And if the physicists are right, and these worlds exist in the quantum foam of spacetime, then where are they? They are in your head, in your choices, in every what-if you've ever thought. What do you think? Would you want to meet your counterpart from a parallel world? Or are you afraid they might turn out to be better than you? Write in the comments. This will be the most interesting debate in this universe. Don't forget to subscribe, so you don't get lost in the multiverse. We still have theories about dark matter, time travel, and the nature of consciousness. And that, believe me,